How's it going, everyone? Welcome. Elvira Gonzalez here. So, in today's video, I want to dive deep a little bit on the principle of least exposure, which is now after we understand about the scopes and variables and how to work with them. The next is from a high level perspective, how now can we use those as a way to apply certain practice and decisions when it comes to build our programs. And that is, for example, of the principle of least privilege, as well as the closure and the model. And that's exactly what we're gonna do in today's video, right? So let's get into this. Subject, no, here we are. So okay, limiting a scope exposure. So far our focus has been explaining the mechanism of how scope and variables work. So with that foundation now firmly in place, our attentions rise to a high level thinking, decisions and patterns we apply across our programs. Okay, that's exactly where the that's why I'm here. That's why I'm here. So to begin, we are going to look at how and why we should be using different level of a scope, functions, and block to organize our program's variable, specifically to reduce scope overexposure. That's why we're going to look at this, right? To begin, we're going to look on how and why we should be using different level of a scope. Again, as a way to apply or as a way to look at this decisions that we have to do in our code, the decisions and the patterns to apply across our program. And as you get into, for example, in React and Vue or Angular, especially on the front end or on the back end, so there is now that kind of questions, right? Is that okay? Now that I know the syntax of this language, all right, in terms of variables and in terms of variables, loops, control flow, like if, for example, or generator, which is another one that go beyond the scope of today's video, but in syntax more specific to JavaScript, so for example, how do you deal with eventual values, all right? But once we know which promise, but once we know at least is the foundations of the JavaScript, so with variables, the iterations, as well as the control flow, right? And also the values, then a question or a high level questions rise, which is then how can we organize is all of these programs in a way that is make it easy for us to maintain and to enhance functionality, right? So this is exactly what we're looking right now. So once we understand now a concept of scope, which is what we did in the couple past videos, so now we're gonna put a place of how to organize all of that when it comes to ask that we made to ourselves as we getting into the code, as we starting to write in this series of steps, this algorithm, right? And how to apply them. So first, we're gonna look at how and why using different level of a scope like function and blocks to organize our programs. variables, specifically to reduce scope overexposure. That makes a lot of sense. So lead exposure. It makes sense that functions define their own scope. Okay. Functions define their own scope, but why do we need blocks to create scope as well? That's a very valid question. The software engineer articulates a fundamental discipline typically applied to software security called the principle of least privilege. You can take a look at that from Wikipedia. That's right. Wait, what? And a variation of this principle that applied to our current discussion is typically labeled as least exposure. So POLP expresses defensive postures to software architecture. Component of the system should be designed to function with least privilege and least access and least exposure, because this is part of the a variation of the security principle, all right, in software, which is the principle of least privilege. In security, according to Moxie Martin Spike, which is the CEO, the founder of, how do you call it? The founder of Signal, a private messaging app end to end, right? That for some reason, he described that encryption, or in the security, they have two, or according to that particular podcast, which is something that I recommend to watch with Joe Rogan. It's the two main strategies here on the security has been the preventing access and encryption, and the first one has shown to be a losing strategy, because this is a defensive posture, right? Again, this is what we have right now, right? So what has shown that has more potential is encryption. So no matter who are there, if that person can have access to that but can understand it, it won't matter, right? So yeah, this is quite interesting about these defensive postures here to software architecture, right? So I would like to know with Claude, what are the defensive postures? So what are the defensive postures of software architecture? Yep, yes it is. What are the defense postures to software architecture? Defense in least privilege, fail secure, and zero trust architecture. Key defense pattern: input validation and sanitization, secure by default, separation of concern, immutable infrastructure, deploy unchangeable components that are replaced rather than modify, reduce surface attack, surface and configuration drift, circuit breakers and rate limited, protect against DDoS attacks or denial of service, and cascading failures by limiting requests and breaking connections to failing service. Security monitoring and logging. Would you like me to dive deeper into this? But in any case, it's describing is this. And what are the aggressive postures? Where can I read more about this from authority authors and websites? You get it. You get the idea. Okay, and while you're doing that, I just want to ask this: what are the attacking posters of software architecture? OWASP, okay, NAST, National Institute of Standard of Technology, SAN, Microsoft Security Development Cycle, practical guide from Microsoft Security Teams here. Martin Fowler sites, Google Cloud Architect, Framework, Security Reliability and Operations Best Practices, AWS Well Architecture Framework, Security Pillar with detailed guidance, AWS Well Architect Framework, and Netflix tech blog for real world security architecture at scale. And this one. No, it's okay. But the other is the attacking posters to software architecture. Kill chain attack lifecycle. Mitre attack and CAK. Real world adversary tactics and techniques organized by attack stage. Industry standard for understanding threat behaviors. Recognizes weaponizations, delivery, exploitations, installations, command and control, and actions and objective. Exfiltration and damage. So common architecture vector are API and service exploitations, broken authentication and authorization, API abuse and exist data exposure, GraphQL REST endpoint enumeration, server misconfiguration, supply chain attacks, compromised dependency, malicious packaging, repository build, pipeline manipulation, third-party services compromise. The part of the supply chain attacks and injections attacks, authentication and seasons attacks. Exactly. Injections attacks. SQL, NoSQL, LDAP, and OS common injections. So what I'm looking at this, data layer attack, database exposure through misconfigurations, data exfiltration via legitimate channel, backup and snapshot theft, infrastructure attacks, container escape, cloud misconfiguration, S3 bucket, IAM, lateral movement between services, private escalation, logic and business flow attacks, race conditions, state manipulation, business logic, logic and business flow attack, race conditions, state manipulation, business logic bypass, workflows abuse. Attacker thinking pattern, low hanging fruit first. Attackers scan for easy wins, default credentials, unpatched systems, exposed systems admin, and misconfiguration services. Persistence over speed. Advanced attackers move slowly to avoid detections, establishing multiple backdoors and maintaining long-term access. Living on the land, using legitimate tools and processes to blend in PowerShell, WMI, SSA rather than deploying obvious malware. Living off the land, targeting trust boundary, exploring where different security zones meet, VPNs, endpoints, API gateway, and service mesh. Resource for understanding attack patterns. Mitre attack, attackmitre.org, comprehensive attack techniques. OWASP, API security top, common API attack patterns, CAPEC, common attack pattern enumeration and classification, and STRIDE, threat model. Spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. Mitre attacks. Mitre ATT&CK is a globally accessible knowledge base of adversary tactics and technique based on real-world observations. The ATT&CK knowledge base is used as a foundation for the development of a specific threat model and methodology in the private sector, in government, and in the cybersecurity product and service community. With the creation of ATT&CK, Mitre is fulfilling its mission to solve problems for a safer world by bringing communities together to develop more efficient and more effective cybersecurity. ATT&CK is open and available to any person or organization for use at no charge. Recognizing research development, initial access. Okay. Execution, command and scripted interpreter, inter-process communication, scheduled tasks and jobs. Persistent, account manipulation, create account, hijack execution flow. Traffic signaling, server component, modify authentication process, privilege escalation, boot and log out, auto start execution, event trigger execution. And then you got a defensive evasion, access token manipulation, abuse elevation. Okay, masquerading, modify system, obfuscated files, pre-OS boot. That's quite interesting. Credential access, brute force, credential from password stores, input, steal or forge Kerberos tickets, unsecure credentials, and the discovery, account discovery, permission group discovery, software discovery, system network configuration discovery, lateral movement, remote service hijacking, remote service, lateral movement to remote services. So again, I'm looking at this. Studnex can propagate via peer-to-peer communication and updates using RPC. Oh, the virus Studnex was the first publicly reported piece of malware to specifically target industrial control system device. Studnex is a large and complex piece of malware that utilizes multiple different behaviors, including multiple zero-day vulnerability and sophisticated window rootkits and network infections routine. Studnex was discovered in 2010, with some components being used as early as November 2008. Okay, last modified 2025. This. Alright. And for the enterprise, from the private sector here. Mitigations. So in any case, this is a very interesting website. Collections, command and control, and exfiltration. Right? Via proxy and web services. Process injections here. Adversary may inject code into processes in order to evade process-based defense, as well as possibly elevate privilege. Process injection is a method of executing arbitrary code in the address space of a separate live process. Running code in the context of another process may allow, oh my god, running code in the context of another process may allow access to the process memory, system network resource, and possibly elevate privilege. Execution via process injections also may evade detection from security products since the execution is masked under a legitimate process. There are many different ways to inject code into the process, many of which abuse legitimate functionality, and these implementations exist for every major OS but are typically platform specific. A more sophisticated sample may perform multiple process injections to segment models and further evade detection, utilizing name pipes and other inter-process communication mechanisms or as a communication channel. Ukraine electric power attack. ABK has the ability to inject shell code into the svc host.exe. Holy hell, so it's able to inject now code that is running into another process. So it's able to arbitrarily executing code in data in the address of a separate live process. You son of a God, oh my God. Holy moly. Woody rat. That has been used since at least 2021 against Russian organization. It's a remote access Trojan that has been used since at least August 2021. Here, that's interesting. Mm-hmm. 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 Mitre. Attack Mitre.io. Mm-hmm. Okay, process injection. Dynamic link library injection. Asynchronous process procedural call, thread location, and all that kind of stuff. So again, I'm reading of this. Okay, I'm reading here because extra window memory injection, prop memory. So I'm reading is because this kind of strategies that Carl Simpson mentioned when it comes to understand is the decisions and patterns that we need to apply to our whole programs. uh, Once you understand now how variables and the scope works that are relevant for our applications, is to understand the is to understand why and how functions and scope limiting it is variable scope is important. So reduce the exposure is a defensive strategy here that in the programs we have so far, right? uh, but I do think that if you are able to encode your code, right, no matter if somebody trying to have access to this, uh, only those who hold the key or know the combination to decode that will know what it's doing, will know what's happening there. Mm-hmm. So here we are exploring is the least exposure, right? In terms of, would say is that it makes sense that functions define their own scope, but why do we need block to create scope as well? So software engineering articulates a fundamental principle typically applied to software security, called the principle of least privilege, which is a defensive posture of software architecture. So, and a variation of this principle applies to our current discussion, which is typically labeled as the least exposure. So, components of the system should be designed to function with the least privilege, least access, and least exposures. So, if each piece is connected with minimum necessary capabilities, the overall system is stronger. So, if the system is connected with the bare minimum capabilities, um, exactly. So if the system is connected with the bare if the system is connected with the bare minimum capabilities, the overall system is stronger. So for example, if for some reason, God forbid, that I lose my fingers, So they compromise, so it doesn't compromise the overall system, right? So you take that from the biology to architecture, the software architecture, and it makes much more sense here. So in POLP, um, in POLP, focus on system level components design. The pole exposure varying focus on a low level, and we'll apply how scope interact with each other. And why do we even care about this? Why do we want to minimize the exposure of poles? Simply, the variable register in each scope. Think of this way: why shouldn't you just place all the variables of your programs out in the global scope? That probably immediately feels like a bad idea, but it's worth considering why that is. Exactly, just to place all the variables on your programs in the global scope. When variables used by one part of the program are exposed to another part of the program via scope, three main hazards that often arise. Exactly. So when a variable is used by other part of your programs and are exposed to another part of the programs, there are a couple things that often arise. So that is, hey, name collision is one of them, especially when a variable is using one part of your programs, or when variables. So when variables in one part of your program are exposed to another part of the program. So what happens is that the name collisions, for example, in the global scope, so it is common to have unexpected behavior for that. The other is the unexpected behavior. This is most common in dynamic programming. So for example, if you expose a variable whose usage is private in a piece of the program, and it allows the developer to use it in way you didn't intend it. So for example, if you have now an array of number, that by exposing that, and you in someone else access and modify that array to include booleans or string, now you are in an inconsistent, and you have you are in an unexpected behavior here. Again, this is solved by typings, strongly types, so it makes a lot of sense. And the other is the unintended dependency. So exposing variables from one part of your programs to another, it has now this unintended dependency. So it creates now, it is make harder to refactor those exposed. It's harder to refactor those who are consuming those variables. And the way to solve that is by creating is a version of the variable exposed for that function, right? Yeah, this is one way of how you can solve this: versioning on unexpected behaviors or name collisions, right? So here we're looking at that of why we want to avoid overexposing variables here. But this is for, okay, in the case of variables, exactly. So if we want to avoid name collisions, it's made clearly to do so. If we want to now avoid any unintended, unexpected behaviors, that this variable is private, but somehow I expose that, and some people may use that. Some developers with ill or no intention, or no bad intention, with ill or no ill intention at all, might get unexpected behaviors across our programs. And then the other is that if you expose now a private method, those who consume that, those who consume that are going to, okay, those who consume that um, when the author of those variables needs to update or do a refactor, it'll make it hard for them to do so. So this is why we look at this particularly examples here of hiding in plain function scope. It should be now clear why it is important to hide our variables and functions declaration in the lowest, most deeply nested scope possible. But how do we do so? We have already seen the let and const keyword, which are block scope declaration. Exactly. So we'll come back then in a more detail shortly. But first, what about hiding var or functions declaration in a scope? It can easily be done by wrapping a function, okay, scope around declarations. And let's consider an example where function scoping can be useful. So the mathematical operation here with factorial, as denoted here, is a multiplication of a given integer against all successive lower integers down to 1. It's a multiplication given an integer against all the successively lower integers down to 1. You can stop at 2 since multiplying by 1 does nothing, but in other words, 6 factorials is the same as 6 times 5 factorials, which is the same as 6 times 5, 6 times 5 times 4 factorial, and so on. So because of the nature of the math involved, once any given integers factorials like 4 has been calculated, we shouldn't need to do that work again, and it's always be the same answer. So if you naively calculate factorial for 6, then later wants to calculate factorial 7, you might unnecessarily recalculate the factorial of all of your integers from 2 up to 6. If you're willing to trade memory for speed, you can solve the waste computation by catching its integer factorial as it's calculated. Exact, because that's part of the trade-off in any programs. It's a speed, memory, and readability here. So here you're defining its factorial, you're defining its a base condition here with the with recursion, all right, with the stop condition, and then you say, hey, if that doesn't exist in the catch, all right, when I evaluate this, hey, is this property in the or is this value is part of this property, it is own property, because that's what it's in is doing in it is own property. No, I don't know. ECMAScript in this is part of the operators. This is an operator. The operators. 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 Control abstract object. No, this is operators for objects. Source, lexical, grammar, expressions, function, script, execution code and execution context, ECMAScript standard built-in object, the global object, fundamental objects, numbers and dates. Fundamental object is, but why this doesn't open? ECMAScript 2026. it is in language and statements, statement semantics, functions. This is the in operator. The assign relational operators. I do think it is relational unary operators. Holy hell. Exponential multiplicated, bitwise relational operators, equality operators, binary bitwise conditional assignment operators, update expression, left hand, primary expression. You know what? Let me find this here. Operator in MDN, and that's gonna lead me to the link here. Yeah, because it's like, and which part is this? Exactly, relational operators. Ah, there you got it. It's relational operators. I was quite close to. It's relational operator. Relational operator. And then you got it with the in here. In here, in, right? So when you look at the in expression and it say, hey, let me evaluate the left reference here of a relation expression, and this relation expression is anything of this, or even in, so you can nest it that, all right? In shift expression, all right, and it say, hey, let me the left value is evaluating this value, so get the value here. Let me evaluate the shift expression and evaluate that, and if error is not an object, throw a type error. But it has an object. Look at it, say, hey, do you have has property of this to property key value, right? It is actually invocating is that hash property. I do think that has property has property here, unlike has own property, has property which is part of the object, all right, has own like this, has own property, is going to check for its own property, and the same for it has own property here. But unlike here within, all right, it's gonna call the has property to this, which is an abstract operation of has property of object and the property key, and returns neither a normal completion and a boolean or throw completion. It is used to determine whether an object has a property with a specified property key, and the property may be either own or inherit. It performs the following steps. So in other words, if you do wants to do something like this, all right, oh my god, come on. So if you do wants to do something like this, as the example illustrate, no, but this is not example. In other words, so that property in property is going to look for that. So you define here is a var with an object, say user, right? And here you define is this, a name, as well as earlier, right? And then you say, hey, do we have this value? Is name in user? Right? I do want to evaluate this, and you say true. Okay, if I say something like this, like has own, it's a false. But if I do now a property here, that's gonna be quite interesting. But if I do is like yeah, but if I do here is uh, mm, mm-hmm. But if I do something like is is keys in user, it's a false. That's interesting. But if you for some reason define out user one, let's say var user one, right? And then you say, hey, this will be now is whatever you have in, so object dot create with the user, all right, and the properties like so, to say, hey, now last name, so if I say something like this on user one, hey, do you have a last name in user one? Syntax error because I didn't close this, you're right. The type error must be an object, the descriptor property descriptor must be an object, or in other words, you can say is this. So now I do want to spread whatever you have in that and check this, and you say, hey, this is true. And the other is that, hey, is a name in the user one, it's a true, but it's a, this is interesting because it is because it is own property here. It is property, not instance method here. It is property, not instance methods. That's interesting. And it is going to look at those inherited methods here. All right. Good. Interesting. Okay, that closed a gap in my knowledge here. That's the prototype. Okay. An object.assign the target and the source. Okay. Okay, so if I want to do this in the old way, is to say, hey, this is now the user, okay, this is now the, so object.assign, what it does is that it say, hey, I have a target that I want to assign or spread this value. So say user, or the object in itself that I want to create, and the source, which will be is, or can be multiple source, the user here. And then you get this. And the other is the object.create, to create the prototype change. All right. Good. So why am I showing this? Well, because as we explore of this particular operators and so on and so forth, we now look at, well, if that doesn't exist in as a property in that object or along the prototype change, well, I'm gonna throw it. I'm not gonna do anything here, right? Instead, if that doesn't exist, I'm going to now compute that and store that in that position as a catch, right? So in other words, it's now calling that function again, where the return function of this is like it's becoming now is the factorial of 4. Let me do this particular example here, because it's in this. So it's like factorial of 4. So for example, if this is 5 minus this, right? But what is this? Well, this is the same to say now on the next call is because it's going to return is the 4 times 4 minus 1, right? So what I'm doing here is just to draw this. Let me use a spreadsheet because I do think that that'll be much more straightforward, like this, whatever it is, just a simple spreadsheet. There you got it. So phi will be something like this, right? Phi, let me put it this here, like this, right? Phi times factorial here. But what is this? Well, this is now 4, okay, 4 times factorial here, okay? So this becomes is now 4 times factorial for 1. And again, what is factorial 4 minus 1 is 3 times factorial of 3 minus 1. But what is factorial 3 minus 1 is 2 times factorial 2 minus 1. And what is factorial 2 minus 1? So if we evaluate this case here, if x is less than 2, you're going to return 1. So in this case, hey, if x is less than 2, you're going to return 1. So in other words, we're going to continue to call that. In other words, if this is 1, exactly, by the time that you call that function again, you're going to get this. this is 1, it's gonna say, hey, if it's less than 2, you're gonna return is 1, right? So now you are returning is 1. So now that we know what is each one of those values, as you can see here, right? Now it is time for us to compute that, which is 1 times 2, 2 times 2 times 3, which is 6, and then 6 times 4, okay, and then 6 times 4 is 24, and then 24 times 5 is 24 times 5 is 24 times 5 24 times 5 is 4 times 5 0 2 5 times 4 yeah, 24 times 5. Mathematics, you need to learn that, you need to refresh that. Yes, so 24 times 5 is 10 by 2 is 120, something like this. 120, I think it is. So yeah, it's 120. So 5 factorial, exactly, he doesn't know how to compute that. Exactly, 5 is 120. Exactly. And then you have 6, which is 700, is this, and so on and so forth. So what we're doing here is this particular computation here. It's like going into that base case, and then let's go into is compute all of those calculations along the way. So anytime that you don't know the path, all right, or anytime that you ignore is the length of the sequence, so factorial is useful to figuring out that, right? Okay. But you need to know is what is the end, what is the stop condition exactly. So instead of recomputing that over and over and over and over and over, we can now is catch the result in a scope that, and enclosing that in a scope like function, and do not expose that. So store that data here using now a closure, all right, which say, hey, I do want is to now use these variables over a long time, over a period of time. And that's how you can get this benefit of this. So the hide catch function serves no other purpose than to create a scope for the catch here, right? So we're creating is a scope for the catch, and creating now is a function that is going to be scope or close over that variable as a way to use that over time. Okay, but it's going to be tedious to define and name the hide the catch anytime that we need it, okay? Especially since we're likely to avoid name collisions. So what we can do here is to now wrap this function, okay, and expose is the function as it is. expose the factorial function as it is, expose the reference of these functions along it is variables that we want to use over time. That's the whole point of this. Variables that we want to use over time, we can close over. So variables that we need to use over time, close over is the way to do this, or a closure is the way to do this. So for example, for keep tracking of stuff is great. Okay. All right. So, but in this case, what we're doing is just immediately invoke these functions, and avoiding is to hide, and avoiding is to define that in the global scope. All right. Just assign the result of that as a value in the global scope only once. So your saving is names here in the global scope. Alright, essentially the same scope as catch rather than in the outer global scope. That means we can name everything single occurring of such function expression the exact same name and never have any collisions. More appropriately, we can name each occurring semantically based on whether it is based on whatever we're trying to hide, and not to worry whatever name we choose is going to collide with any other function. That's what we use. This is one of the main excuses of using immediately function expressions. You're now going to encapsulate is variables and functionality, right? That you don't want to use those identifiers in the global scope or in that particular scope. You just want to run that immediately and save yourself an identifier, aka preventing you to preventing an entire classes of bugs. So for example, name collision is the most straightforward, and the other is unintended exposure dependency, or unexpected behaviors. Here, what am I not seeing here? What am I not seeing here? That's my question here. What am I not seeing here? So what happened to the name identifier to the function expression? Since hide the catch is defined a function expression instead of a function declaration. It is naming its own scope, essentially the same scope as catch. Exactly. And here is now defining the scope for these variables, var and function. That means we can name every single occurring of such function expression the exact same name and never have any collisions. For more appropriately for that, it is also describing as this, invoking function expression immediately. There is another important bit of this previous factorial recursive program that is easy to miss. The line at the end of the function expression that contains this. Notice that we have surrounded the entire function expression in a set of parentheses, and then on the end we added the second parenthesis. Parenthesis set, that's actually calling the function expression, which is defined moreover in this case. The first set of surroundings around the function expression is not strictly necessary, but it's just for the sake of readability and convention of immediately function expression. You can also have other type of that. An immediately invoked function expression is useful when we want to create an scope to hide variables and functions that avoid name collisions, that avoid unexpected behaviors when we expose variables identifiers to other part of our programs. And the other is the unexpected behavior by exposing them. So this is true for scripting language, but not for TypeScript language or not for type language. Since it is an expression, it can be used in any place in JavaScript program where an expression is allowed. An IIFE can be named and with hide the catch, or much more commonly, unnamed anonymous, and it can be standalone or, as before, part of another statement. Hide the catch, return the factorial function reference, which is the assigned to the variable factorial. So for comparison, here is an example of a standalone IIFE. Unlike early with hide the catch, where the other surroundings we notice as being an optional stylistic choice for a standalone IIFE, they are required. They distinguish the function as an expression, not as a statement. For consistency, we use this IIFE. But technically, the surroundings are only syntactic way to ensure the function is an immediately invoked function expression. It's treated by the JS parser as a function expression, and we look at some options in the appendices, and I already looked at them. So function boundaries. Beware that using an IIFE to define a scope can have some unintended consequence depending on the code around it. Because an IIFE is a full function, the function boundaries alter the behavior of certain statements and constructs. So for example, a return statement in some piece of code will change its meaning if IIFE is wrapped around, because now the return will refer to the IIFE function. Non-arrow function IIFE also changes the binding of this keyword. More on that in the object and class book. And a statement like break and continue won't operate across IIFE function boundaries to control an outer loop or block. To control our outer loop or block of the IIFE function boundaries. Exactly. Because this is now a full function here, and so if the code you need to wrap a scope around has a return, if the code you need to wrap a scope around has return this, break, or continuing it, IIF probably not be the best approach. In that case, you might look to create the scope within a block instead of a function. But all of this is just to look at var and functions, and how can we now create an own enclosing scope with var and functions to help us save names, so to avoid name collisions, and then unexpected dependency and behaviors. As he mentioned here, unintended dependencies that you might expose, and the other is a scoping with blocks. You should by this point feel fairly comfortable with the method of creating scope to limit identifier exposure. So far we have looked at doing this via a function by scoping that, but let's consider using a let declaration with nested block. In general, any curly brace paired with a statement will act as a block, but not necessarily as a scope here. A block only becomes a scope if necessary to contain its block scope declaration, let, and const. So for example, like this is not necessarily a scope yet until this. Now we know that the block needs to be a scope, or JavaScript needs to know that. For let, so now JavaScript needs to know that this block is an scope, but not this one. And this is just a block, not an scope. And not all curly braces create blocks and thus are eligible to become scopes. Obviously they don't use curly braces, but they are not scope. classes use curly braces, but they are not scope or a block. But this is not a block or a scope. A function used around its body, but this is not technically a block. It is a single statement for the function body. It is, however, a function scope. And the curly brace pair on switch statements around the set clause does not define a block or a scope. What defines a scope is with the catch in the try-catch statement. What defines a scope is a curly braces when a let in const declarations are found. But again, all of this based on the observable behaviors. Explicit standalones like this, blocks has always been valid as syntax, but since they couldn't be a scope prior to EX6 let in const, they're quite rare. So, however, post ES6 that starting to catch on a little bit. In most language that support block scoping, an explicit block scope is an extremely common pattern for creating a narrow slice of a scope for one or few variables. So following the Paul principle, we should embrace this pattern more widespread in JavaScript as well. Use explicit block scoping to narrow the exposure of identifiers to the minimal practical. Why you are doing this? Because I want to limit. Exactly. I want to narrow the exposure of identifiers to a minimal practical. Right? So if I need that particular name, if I need that same name out of the so if I need a particular identifier out of the outer the block scope, if I need that identifier, if I need to define that identifier out of the block scope and use it inside of the nested scope without shadowing, that's okay. And here the curly brace pair inside of the if statement if an even smaller inner explicit block scope of the message. So for example, like this. So this is both a block and an explicit scope. And this is a block but not in a scope. Exactly. So does it matter enough to add the extra pair of indentation level? I think you should follow the poll and always within reason define the smallest block for each variables. So I recommend using the extra explicit block scope as shown. Recall the discussion of the TDC error from uninitialized variables here. A temporal dead zone is to. So my suggestion there was to minimize the risk of TDC with let and const by putting that at the top of their scope. So if you find yourself placing a let declaration in the middle of scope, first think, oh, TDC alert. If this let's declaration isn't needed in the first half of that block, you should use an inner explicit block scope to further narrow its exposure. Another example with a explicit block scope is this. Like so. Let's say, hey, I'm going to define this top level variables, top level identifiers variables, right? And then if I need to compute something, because that's what it's doing here, if I need to compute something, let me now define some variables here and then update those outer reference here. But this is more a substantial example here. So if for some reason I'm going to sort names by length. So I do need to have all of these particularly buckets. All right. This is a good analogy here when it comes to defining this algorithm and so on and so forth. So I'm gonna define all of these buckets here. Okay. In each one of these buckets, right? what I want to put here is now is the length of this word. All right, and how do you do that? Well, whatever position you are in these collections, I'm going to know is add to this bucket all of these words with this same length. Okay, which is exactly what it's doing here. Hey, is the first name in the names? Let me check the length of that, and if that doesn't, let me check the length of that. And if I don't have any, and if that position I don't have any bucket here, or if in that position I don't have any length, I don't have any item here, well, let me actually is add that and create here is a collections of elements that I want to put here. Right? You can think of it like a stack of elements or a collection here. But putting things like in a stack is also helpful. It's a good mental model here. So once you put all of this in this stack, all right, so now you have this particular bucket. You have this particular bucket with all of these different stacks of words there, all right. And the only thing that you need to do is, if you want to sort them, each one of them, you're going to now iterate through those buckets, all right, in order by length, all right, and on each one of them, you're going to now sort all of them alphabetically and return that. The same for this and return that, and the same for this and return that, and so on and so forth, right? So in other words, we should get is the Sally, Susie, no, I mean is John, John, return by length, exactly, return by length. So it's a hey John, Susie, Frank and Sally, and Scott, and then Jennifer here. There are 6 identifiers declared across 5 different scopes. That's right. And could one of these variables have existed in a single outer global scope? Technically, yes, since they are all uniquely named and thus have no name collisions. But this will be really poor code organization and will likely lead to both confusion and future bugs. We split them out into each inner nested scope as appropriate. Each variable is defined in the innermost scope possible for the program to operate as desired. Exactly, and then you are now returning is a sorted name. Sorted names could have been defined in the top level function scope, but it's only needed for the second half of this function to avoid overexposing that variable in a high level in a higher level scope. Again, we're following is a poll here. So that'll be all for this video. Take care. Bye bye.